Thank you. Thank you very much for inviting me to present the work we do in Trinseo. So my talk will be focused on PMMA recycling. So a few words about Trinseo first. So Trinseo has different activities in recycling. First, there is a laser pointer. Yeah, mechanical recycling through the acquisition of a Dutch company, Island, which is specialized in collecting kind of specialty polymers like PMMA, of course, polycarbonate and others. Island has an activity to collect, crush, and mechanically recycle some polymer. The other activity in Trinseo in Netherlands is related to selective dissolution type process for polycarbonate and ABS. So in this technology, a specific solvent is used that dissolves specifically the targeted polymer and not the other one, and after the polymer is recovered by precipitation. The main activities I will present this time is related to thermolysis. So it's a process where heating a polymer, it depolymerizes and releases the monomer. So this is the plant we have started 1 year ago in Rho to depolymerize PMMA and produce the recycled monomer MMA, methyl methacrylate. So this is the location of the site. So it's maybe 15 minutes from here in Rho, where the site is already producing the virgin monomer, so the methyl methacrylate, and of course already some resin. And that's the site where we have constructed the demonstration plant, where we have this new process. Okay. There are different type of technologies for recycling. It was presented just before. I will quickly go through it. So it was mentioned you can have incineration. It's not really recycling because when it's burnt, it's too late. Gasification is not really a recycling process because you don't make the same product again. It's just material valorization. Then you have the pyrolysis technologies, which are used for the mixed plastics. And the thermolysis that I mentioned. So both are using heat. Yeah? That's why I say some like it hot. We use heat. It's a high temperature process. It doesn't mean that it's a high energy process. Yeah? There is usually a lot of confusion between heat, energy, temperature, and power. Yeah? So it's a high temperature, high power, because we want a very productive system. So we want a lot of energy in a very short time, but it's a low energy consumption process. Okay, the other type of technologies which are possible is solvolysis. It was mentioned before, which is appropriate for PET, for polyamide, for polyacetal, for PLA. So in this case, there is a chemical reaction. The solvent is a reagent. The variation of that with enzyme and water. And then you have selective dissolution processes, which is more a physical process. The main difference is that with those technology, you change the molecular weight. You get monomer or oligomers. With selective dissolution, you don't change the molecular weight, like for mechanical recycling. What I would stress is here, I've put this picture, Ghostbuster Legacy. The challenge that we have in recycling is that there are plenty of additives which have been put in plastics, and some of them are no longer allowed today. So we need a technology, so mechanical recycling cannot do that because it will not be able to remove these additives from the plastic. It will be trapped in the plastic. Selective dissolution with the right material is also able to remove some additives, so in this case it's appropriate. But that's the challenge for the technologies that we develop, is to be able to remove additives that are no longer allowed today. So that's why depolymerization is quite appropriate. Okay, back to PMMA. Especially in Europe, to make the virgin monomer and virgin polymer, we use a technology based on acetone. So acetone is a raw material, but we also need natural gas, ammonia. We need also sulfuric acid. Yeah, we produce the monomer, but also ammonium sulfate in the process. And what is also important, we need a lot of what we call critical raw materials. For example, we need platinum in one of the catalytic steps. And so we need graphite for one of the process equipment, and so on. So each time we produce virgin monomer, we also need a lot of natural resources which are not renewable. Yeah? Of course, when we use recycled monomer, we didn't use these other natural resources. So we have produced the monomer. The monomer goes into, let's say, the industry, the consumer. Our partner, Iceland, in this case, collect those material. There are many different types of PMMA. You have PMMA for injection molding, for extrusion, PMMA for cast sheets. Some of them can be mechanically recycled. Usually, maybe this is maybe appropriate if it's extrusion sheet, transparent, clear, no color. Then in this case, if we can recycle mechanically, we can put a pigment, and that's fine. But PMMA is also sold in many different types of colors. And then unless you want to make a black product, it's impossible to recycle mechanically. And the depolymerization technology in this case is appropriate. So now we have the Altuglas AirLife. This is the brand name from Trinseo, the AirLife MMA, and the AirLife PMMA, whether cast or mechanically recycled. As I mentioned before, the process on PowerPoint chemistry is very simple. You just have to heat the polymer above 350 degrees C, and it will depolymerize. It generates the monomer that we can recover, and this is the recycled monomer. Yeah? On PowerPoint, it's always very easy. The same type of chemistry can be used for polystyrene. It was mentioned before, and some mixed polyolefin. But with mixed polyolefin, it's not selective. You get a mixture of molecule. Okay, PMMA depolymerization is not something new. There were many plants in the past in Europe. ICI had a plant in UK. Arkema had a plant in France. Evonik had a plant in Austria, Parachemie, which is closed. Those plants are closed. There were also plants in Portugal, in Spain, and so on. A lot of plants have been closed. They were all using the so-called molten lead bath technology. So you have molten metal at high temperature, 400 degrees C and more, and you pour the PMMA into this molten metal bath, and there is heat transfer, and then the polymer depolymerized. These plants have been closed, but there are still some plants in operation. So Madreperla here in Italy, Monomeros in Spain, and in the future, the Biorenova technology might be implemented also here in Italy. There are also in Spain a small production from a small producer, JRPD, Acrylgraph, small capacity in Italy, and MD2 with a different technology. The choice that we made several years ago already through in the EU project MATU was to use an extruder. So we have a high temperature extruder. We feed the extruder, so there is no contamination with other metals. It's just a direct process. What I want to stress with this graph, so we surveyed many different plants which are recycling PMMA through depolymerization. What I want to stress in this case, so here you have the yield, so kilogram of monomer per kilogram of polymer feedstock, and the purity. Yeah? So all different type of plants, different type of technologies, and so on. Of course, as usual, when you want to increase your purity, you decrease the yield, you lose product. So our case is, of course, on the top right corner, high purity, high yield. What I want to stress in this case is when you have a technology which is able to achieve 90% yield, and whatever the purity, but the higher the purity it is, 90% yield, it means that you can recycle 6 times your polymer and still keep 50% of the carbon in the economy. And this should be our driver for sustainable technology and sustainable materials, is to keep as long as possible the carbon in the economy. Okay. Last slide, just to show some products that are available from Altuglas and Trinseo today. So there are some material, whether chemically recycled, different composition for the automobile industry, for capstock, for design, consumer application, for cosmetic packaging, for example, also for sanitary grades. And of course, we have the monomer available. If you want to learn more about that, you can refer to some papers that are in the press, in chemical engineering. We made a paper. We made a book 2 years ago, and the new edition will be published in July. So if you are interested to learn more, don't hesitate. And finally, thank you for your attention. If you are interested, I have also some colleagues in the room. They can supply information. Thank you.